Okay, so I'm going to show you how to do quadratic regression with the TI-84 that looks like this. So first thing I'm going to do is turn it on. Okay, so a player hits a tennis ball across the court and records the height of the ball at different times as shown in this table. At 0 seconds it was 5.5 feet. After 1 second it was 6.0 feet. So we are going to find a quadratic model for the data. We're going to use that model to estimate the height of the ball at 4 seconds, and we're going to find the maximum height of the ball. So what I want to do is I want to put these two lists into my calculator. My list of inputs, my list of outputs. So that is under Stat, and then Edit. And this takes me to the place where I can enter my lists. So for list 1, I'm going to do this column. 0, 1, 2, 3. Then for list 2, I'm going to enter these values. 5.5. Make sure that they correspond. 0, 5.5, 0, 5.5. And then 6.0. Then 5.5 again. And then 4.0. Alrighty. Now that my data is in there, I can take a look at a plot of those data points by doing second and then stat plot. Make sure, see right now it says plot 1 is off. Plot 1, that's L1 and L2. So what I'm going to do is I'm going to turn that on. And then this image right here shows me that it's going to be a scatter plot. I got my X values as list 1, my Y values as list 2. So I'm happy. And I'm just going to take a look at the graph by clicking on Graph. So those are my points. Now what I'd really like to do is find an equation of a parabola that goes through those points. Here's how we do it. We are going to click on Stat and then move over to Calculations and go down to Quad Reg, which stands for Quadratic Regression. And that is going to find, according to the X values that we put in list 1 and the Y values we put in list 2, it's going to find the equation of a parabola that goes through those points as close as possible. We want to store our regression equation so that we can graph it as y1. And then we will calculate. So it will go ahead and calculate what A, B, and C are for us. So let's make a note. Negative 0.5 for A, 1 for B, and 5.5 for C. And then just for funsies, let's go look at it, just chilling right there in Y1, already there for us. Thank you, Mr. Calculator. Now let's go look at the graph. It shows our plotted points, and then it's going to graph the parabola that goes the best through them. And it just happens to be right on through them. Okay, so we can now answer part A. Find the quadratic model for the data. And the quadratic model is y equals negative 0.5x squared plus 1x plus 5.5. That is the quadratic regression equation that the calculator gave us. Now we can use this model to estimate the height of the ball at 4 seconds. So 4 seconds would be right here. So I'm just going to plug that in for my x value. These were my x's, these were my y's. So I'm going to plug in a 4 for x. Y equals negative 0.5 times 4 squared plus 4 plus 5.5. So that's negative 0.5 times 4 squared is 16 plus 9.5. Well, half of 16 is 8, and negative of 8 is negative 8. Plus 9.5, we get y equals 1.5. So the height of the ball at 4 seconds would be 1.5 feet, because we're measuring in feet. And then what's the ball's maximum height? Well, the maximum height would occur at the vertex. So we can find the vertex by doing negative b over 2a. So that's negative, let's see, b is 1, over 2 times a, which is negative 0.5. So that's negative 1 over 2 times negative 0.5 is negative 1. Negative 1 divided by negative 1 is 1. So our vertex has an x value of 1. We might also just say that h equals 1 here. And then I just need to plug a 1 in for x to find what the height is, but oh look, I don't even have to because there it is. When I plug in a 1, I get 6 feet. So the ball's maximum height is 6 feet. And there you go, friends. Enjoy!